Waves in our ocean are an incredible source of power that could, in theory, meet the whole of global electricity demand. However, harnessing wave power has been a centuries-long quest, littered with failure. But that could all be set to change. A floating wave energy converter called the C4 by Sweden's Core Power has taken inspiration from the human heart and combined it with world-class engineering to deliver some incredible results. In this video, we'll look at the design that allows the C4 to capture a reported 5 times more energy per ton than other wave systems. However, before they started optimizing the energy from their device, there was a bigger challenge they had to solve, and that was making sure the whole thing didn't get ripped apart in the ocean. When I studied wave energy at university, it was like a post-mortem of failed systems. Since 1799, ideas and patents have come thick and fast. These ideas have yielded devices with fantastic names, like the salted duck, mighty whale, and the oyster. There are now more than 1,500 wave energy patents out there, but commercial success has been elusive. This is largely because wave power has historically had 2 very expensive problems: efficiency and survivability. So, to really test the survivability of their invention, the Core Power team chose to do their testing off the coast of North Portugal, where their system was subject to 4 powerful Atlantic storms. And amazingly, it survived all of them without a problem. One of their secrets to this incredible survivability is that Core Power uses composite buoys that are lightweight and tough in a type of wave energy converter known as a point absorber. Tethered to the seabed, they oscillate with the waves, mostly up and down, capturing wave energy. The C4 harnesses the linear up and down movement and turns it into rotation, creating electricity via a cascade of small gears powering an onboard generator. Even with safety constraints on velocity and stroke, the 6-month test in Portugal achieved a peak power of 600 kilowatts. For comparison, wind turbines with equal power ratings are twice as tall with rotors 4 times wider, and much more complex to deploy. However, just using tough buoys is not the ingenious invention that sets Core Power apart. Instead, there are a few other breakthroughs that help address the system efficiency and survivability in much more interesting ways. One of these is called the wave spring system, that builds on an older breakthrough, a hydraulic pump invented by a cardiologist. The cardiac cycle takes less than a second, but as cardiologist Dr. Stig Lundback discovered, it's mind-blowingly efficient. This is, in part, because the heart only uses energy when it contracts and pushes blood out into the body. To fill back up, all it needs to do is relax and let pressure in the rest of the body push blood back into it. This means that with one contraction, blood flows in 2 directions. This idea of using built-up pressure to get blood flowing in 2 directions from one action is what got Dr. Stig Lundback thinking about wave energy. Because, just like the heart, waves only push in one direction. In 1984, Dr. Lundback patented the dynamic adaptive piston pump. Like the heart, it's a single pump with a dual action. Decades later, he co-founded Core Power and put this mechanism to good use. However, unlike the heart, the Core Power C4 uses pneumatic systems, meaning that they work with air instead of fluid. As the buoy rises in a wave, the central pneumatic cylinder and springs store up the pressure. Then, this stored pressure can provide a returning force as the buoy goes back down, where the central cylinder pulls back on the rods that are secured to the ocean floor with an anchor. Therefore, the C4 buoy can capture the maximum wave energy throughout the whole cycle, instead of just the upstroke. This pneumatic system also helps with survivability. This is because when a storm comes, the pressure can be increased inside to prevent the buoy going all the way up and down with the harsh ocean waves. This state is known as the detuned storm protection state, and can be compared to a wind turbine pitching its blades during high winds. This ability to shield itself from large waves is how the C4 survived Atlantic storms with record-breaking waves of 18.5 meters. However, when the waves are good, the C4 buoy can instead be continuously tuned to work with the waves. This tuning is done using the onboard generator alongside the wider wavespring system. The wavespring was invented by Dr. Hals. When designing this system, he had to do lots of 3D modeling and testing, which is why before looking into the wavespring further, I need to tell you about today's sponsor, Onshape. Onshape is a professional grade computer-aided design software that is completely free for all makers and hobbyists forever. It's even free for engineers and companies for 6 months so they can properly try it out. It's amazing that we live in a world where you can log onto a website without downloading anything and within 2 minutes be making anything your mind can think of, like I've done with so many projects. Because Onshape is built with a cloud-native architecture, it enables features such as real-time collaboration, seamless integration with mobile and tablet use for iOS and Android, and built-in product data management. Cloud autosaving also means you won't ever lose all of your work halfway through a project. File sharing can also be as simple as just sending a link, like the ones I've left in the description. Onshape is continuously adding new features, so make sure to go and get a free account using my link onshape.pro/Ziroth and start making whatever you can think of, and that link is also down in the description. Now to look at how the wavespring and generator work together to maximize energy from the waves. By allowing the pneumatic springs and cylinder to compress and expand, hence storing energy and releasing energy, it shifts the movement of the device more in line with the waves. A smart control system also chooses how hard the generator works, so it extracts energy at the perfect time. This further helps to ensure the buoy continues to move in phase with the waves, which is best for maximizing power extraction. One of their scientific papers claimed that this increases the overall energy extraction by 3 times compared to a passive system. An analogy for how this works is like a well-timed push on a swing. By managing when energy is stored or released, the motion of the swing, or buoy, can be optimized. Just like pushing a swing at the right time, using the generator to control the flow of energy can keep everything moving in time and improve energy efficiency. I briefly mentioned this earlier, but in order for the buoy to pull or push itself back towards the ocean, it needs to be tethered to the ocean floor. Each buoy is anchored to the seabed by a tensioned mooring system called the UMAC, or Universal Mooring, Anchoring and Connectivity Kit. According to Core Power, the UMAC anchor outperforms gravity anchors and conventional monopiles in terms of holding capacity, cost, and carbon footprint. It is also installed with a high-speed and low-noise method, making it friendlier to marine life. As well as withstanding extreme forces, it also acts as a secure path for electrical cables to come from the buoy. The wider vision is to have arrays of buoys or core packs laid out side by side in sets of 5, 10 and 30 megawatts to form wave farms. From here, electricity will be delivered to the grid collection hubs connected to a single export cable. Amazing technology aside, the real driver for these innovations is the final levelized cost of electricity, which measures the average total cost to produce 1 unit of energy over the lifetime of the system, factoring in construction, operation, and maintenance. Here is what Miguel Silva, Managing Director of Core Power, had to say on the topic in an interview he did with the team at Enlet, who I'll leave a link to in the description below.
The design from the device and the concept behind it has always LCOE as the main metric, so the levelized cost of electricity. So when you design the machine and each of its components, you're thinking about the levelized cost of energy. So for example, on the C4 that you see behind us, you have a composite hull. It's a choice for LCOE. It's a choice that moved us away from traditional hulls of steel that are very vulnerable to raw material price fluctuation, and we moved to a high efficiency, mostly fully automated process to manufacture from resin and fiberglass. So this immediately gave us a 70% reduction on LCOE. So this is an example how the design is tuned by a metric that is feeding to one of the big targets. It has to have a competitive technology in the market.
Reports say that when a cumulative capacity of 600 megawatts is installed by 2025, the levelized cost of energy will be around $75 per megawatt hour. I've also seen that if they can install 20 gigawatts of these boys, it will drop as low as $35 per megawatt hour, which is competitive with wind and solar. This cost-driven approach is also how the UMAC anchor was born. Core Power says that its installation by Vibro Hammer is 15 to 20 decibels quieter than any other method, which would really help underwater noise pollution, and I love the way that it came about.
When we thought about the mooring system, there were anchors in the market were very expensive. So the company decided, okay, let's stop and think, let's do our own anchor system. We have always a collaborative approach where we work with private sector and with academia all together. And we got this very nice universal mooring anchor that will be a solution for wave energy, but also for other markets. For example, floating offshore wind, and all these are winds.
After the success of the C4 tests, they'll now be testing for all of the arrays, which will also be done off the north coast of Portugal. With more buoys out at sea in bigger arrays for longer periods in potentially even bigger storms, a lot is riding on how well they survive the violent and corrosive ocean that's been the nemesis of so many systems. But so far, things are looking positive. With continued investment, it might not be long before Core Power arrays can provide significant renewable power to our energy grids in coastal regions. What I love about engineering is how innovation builds, sometimes over centuries. Layer on layer of success and failure add up. With Core Power's breakthroughs and continued development, commercial wave power is a lot closer than it was, and I can't wait to see how they get on. If you've enjoyed this video, please subscribe. It's free and helps me continue to bring videos on the sustainable engineering that's happening around our world. You might also like a recent video I did on these really efficient LEDs that were inspired by nature and fireflies. And if you've got other subjects you'd like me to explore, please leave them in the comments below. Thanks for watching.